Concept 3, using slope-intercept form to graph. So if you're given an equation that is not in slope-intercept form, one of the most straightforward ways to graph that equation is to convert it to slope-intercept form so that you have your slope and your intercept right there, and you can easily graph the line. Okay, so slope-intercept form, again, y equals mx plus b. This is the most important part. The y is isolated, it's all by itself. There's nothing that you're multiplying or dividing by y. It's just y. Okay. So my first step is going to be to move any other terms I have on that side of the equation over to the other side. So I'm going to subtract 2, 4y equals 10x minus negative 6 minus 2 is minus 8. Then divide. To isolate my y, I divide every term by that number. This cancels, and I end up with y equals 10 over 4, or I can just simplify that real quick, 5 over 2x minus 8 over 2 or 8 over 4 or 2. Okay, and this is how I would like your slope to look. Okay, instead of being an improper or a mixed number, I would like it to be an improper fraction. It should never be a decimal. Fractions are easy to graph, fractional slopes. Decimals are very difficult to graph. Okay, because if I'm doing this one, my y-intercept is negative 2. And then I'm just going to go up 5, 1, 2, 3, 4, 5, over 2, 1, 2, and there's my next point. And it's very easy. If I had this as a mixed number, right, 2.5, I could get to the same place, but I would be going up 1, 2.5, and over 1, and yeah, that's a point on my line. But when you start trying to graph partial slopes, so something that's not whole numbers, it's easy to get your line off. Okay, and if I tried to graph with 2 points, one of which wasn't exact, my whole line would be off. Okay, so leave it as a mixed number. All right, next one. Let's change color. I guess I should graph this. And something along that line. Okay, and we'll put our arrows so that everyone knows that this line continues on forever. Okay, now second one, we have negative 4 and negative 4. Add 4 to each side. Okay, and what happens actually is these both disappear, and I'm left with negative y plus 2x is equal to 0. Okay, hopefully from the last lesson on direct variation, you can recognize that right now this is going to be a direct variation equation. Okay, because I've got that 0, because my y-intercept is 0. But we can continue and put this into slope-intercept form, okay, which even if it has the 0 there, basically is going to be a direct variation equation, but that's fine. Okay, move our 2x over, minus 2x, negative y, those cancel, equals negative 2x, and here I am dividing by negative 1, basically. Divide by negative 1, and I'm left with y, my negatives cancel, y equals 2x. Okay, and I could have a plus 0, or I could leave it off. It doesn't really matter. Either way, I know that this is going to be my point, right? My y-intercept right at the origin, and then I can count up 2 over 1. There's going to be my next point, up 2 over 1, up 2 over 1. Looks like they cross about there, and I can just keep counting to get my slope. Okay, and it'll end up being, not a very straight line, but something like that. All right, last one. This actually is an equation that's already in standard form. So we could, back to, let's see, lesson 3, we could graph this by finding the intercepts, and that would be fine. Or we can put it into slope-intercept form quickly and graph with that method. Personally, that's the one I prefer. I prefer doing everything out of slope-intercept form. But if you have an equation like this and you'd rather find the intercepts, that's okay too. All right. So first step, move the term over. Okay. Cancel. We have negative 3y equals a negative 4x plus 24. Divide by negative 3 to isolate our y variable. And this is, although we've done it, in these other ones, this is the situation that a lot of students will mess it up. If you're dividing to get your y by itself, every other term you need to divide by the same number. Okay, you can't just divide 2 terms and leave this as 24. It'll be the wrong answer. Okay, so I'd have y equals negative 4 over negative 3, or 4 over 3 x plus a negative, because I got a negative there, 24 divided by 3. And we'll just leave it as 24 thirds. Okay, and this one obviously is going to be a little more difficult to graph because I'm going to start at negative 24 thirds for my y-intercept. So this one you might just decide to say, okay, I'm going to plug in 2 values for x and I won't use the y-intercept. And that's fine as well, as long as you are finding those 2 points so you can build your graph.